We're going to talk about 10 TC circuit basics. Okay, so here are the things that we will know in this lecture. First, we'll talk about the schematic diagrams. Okay, and then circuit simplification and rules of significant figures, Ohm's law, current and voltage calculations, resistance calculation, power calculation, also resistances, series and parallel, and division of power, and lastly combination of series and parallel connection. Okay, so let's start with the schematic and symbols. So you can see some of the in the later part of the class you will see some figures or diagrams like this. So we call this one resistors. The first one here is a typical resistor that you can see, and sometimes it talks about a variable resistor. So this is the symbol or the diagram. Okay, and then this one is a potentiometer. Okay, potentiometer is a, you can change also, it's a variable resistor, but you can change it and then fix it, no? So well, all of these can be represented by a symbol resistor. Okay, then we also have batteries. Okay, or voltage source can be represented by this one, a single cell or a multi-cell battery. Then we have meter symbols. Other than this, we also have current meter, voltmeter, and sometimes it's just simply depending on what meter. So for example, voltmeter, so we simply write V, okay? Or if current meter, we also write A, so ammeter, okay? Or kung, these are the typical uh, meter symbol that we're going to use. And then we have other symbols, no? Or something like, for example, we have incandescent lamp, then we have fixed capacitor, inductor, okay, with air core, and then we have laminated air core with the symbol here, and then we have earth ground, and then we have sorry, this is chassis ground, and then this is the earth ground. This is the most commonly used, um, and then we have alternating signal generator, and then we have here a pair of terminals, so this is open, and then whatever um, component or device. So sometimes we represent this one as load, or just simply like that, no, a box or a rectangular box, no. And then you just simply write the name, like sometimes the label is a resistor or maybe a load, or something like a device, no. So load, so okay, so anyway, so these are the um, symbols that you can find in the wiring diagrams, no? So wiring diagrams are simply okay, so we'll talk about it. So schematics illustrate the interconnection between components in a circuit or system, while wiring diagram provides a more detailed circuit sufficient for any technicians to use for its repair or construction. So actually, you can interchange the two. Okay, so schematics or wiring diagram, but um, schematics is simply a interconnection, no, between components in a circuit. So wiring diagram is also an interconnection or schematics, but more detailed. Okay, so for a person with art, no, or skill in circuits, so he can understand, compared to a normal person may not be able to understand the circuit. Okay, so but schematics is intended for general use, and then wiring diagram is a term for most of the technicians. Okay, so this is an example of a circuit, and for simplification, you have a very complicated circuit, but you can actually simplify it, no? So for example, you have a resistor, you can represent this as your device, the device that consumes current, and then with a potential difference E. Okay, so it can be simplified by its major voltage, current, and resistance. And then later we will talk about principle on that we call Norton or Thevenin equivalent circuit. So from a complicated circuit, we simplify it into the principal circuit. Okay. Now, competent engineers or scientists go by the rule of significant figures. So we've learned this one in our basic science, no? Also called the rule of significant digits. Okay, so we know, for example, 0.010. This has two significant figures. Okay, now after completing a calculation, so whatever calculation we have, for example, we have resistance, value of this and that. Okay, always round the answer to the least number digits given in the input data. Okay, numbers. So for example, the least number of digits. So for example, this is your current. Okay, and then you have resistance 2010 ohms, for example, and then voltage equals to 15.5 volts. Okay, now so the answer, if you're looking for power, for example, and then you're using VI, then the power should be equal to 0. If you multiply V times I, it becomes 0.15. Sorry, 16. Now, instead of 0. Uh, yeah, we know that voltage has three significant digits, current has two, so therefore the output should be two decimal or two significant figures. Okay, so the least number of digits given in the input data number. Now, if you're going to use later, we will know this formula I squared R. Okay, still the answer should be in two significant figures. Okay, because you're involving I. Now, if you're using voltage and resistor, okay, we will learn that formula later. So we have three. So we have this one has and the least is three significant figure, which is the voltage. So the answer should be somewhere. For example, if we compute that one, maybe let's say 15. So let's say maybe 3000. So 30. Let's say this is an example. 30.5 kilowatts. Okay, or times 10 to the negative. So this is a 3-digit so the 6, for example, no. So just this is just an example. So the result will be three significant figures. Okay, so you need to use this notation times 10 to the power of 6. Okay, for example. So there are three significant figures. Okay, so that's it, no? So simplification and significant figures. Now let's proceed to Ohm's law. So this we already introduced this one from the previous topic. Now this is a very simple mnemonic for us to remember. So we know that V equals IR or E equals IR. So E is equal to I times R. Now if you're looking for current, so E divided by R. Okay, and then if you're looking for resistance, just look at the diagram. So the above equation is E over I. Okay. Another way of remembering this is simply remember this formula. Okay, V equals IR or E equals IR. Then that's it. No, don't worry. Okay. And then warning, use the proper units. Most of the time, the given circuit is in mega ohms, kilo ohms. Okay. Now, when you calculate, you should use the actual number. Okay, like 13,500,000, not mega, like 13.5 only. Okay, so you need to use the proper unit or standard units. Okay, but sometimes when you write it in your circuit or when you're drawing a schematic, you will just simply use 13.5 mega ohms, for example, no? Or mm ohm. Okay, just to you don't write this big number, no. So but when you calculate, remember to use the standard unit or standard value. Okay. So let's proceed to current calculations. Okay, so we have this circuit here. We have a source, a DC source, and then we have a voltmeter here, and then we have a current meter. Now, don't think that they're part of the circuit. Actually, they're part of the circuit, but they don't affect the circuit. Okay, so you will understand this one later in the more advanced topic. No, that simply you added voltmeter here and current meter as series, but they don't get significant energy from the source. Okay, so you just simply ignore, you can simply ignore them in the circuit. Okay, and the purpose that we're writing them or drawing them is that for the sake of getting the values of current and voltage. Okay, so actually the actual circuit is simply the voltage source here. Okay, so actually you can represent that one as uh, like that, and then a potentiometer. Okay, we have a potentiometer here like that. Okay, so potentiometer is simply with a resistance. Okay, now suppose that DC generator, so this one we call a DC generator. Okay, so um, figure produces 36 volts. Okay, and we set the potentiometer to 18 ohms. Okay, so what will be the current flowing? Okay, now take note, the voltmeter, if you put the voltmeter here in these two nodes, the result will be 36 volts. Okay, because that will be the value of your DC generator. Now for the current, whatever the ammeter, whatever the value in the ammeter, so that will be the value for your current. Okay, now using Ohm's law, we can solve this one. I equals V divided by R. Okay, or V equals IR. So voltage is equal to 36 divided by 18. So this is equal to, so we have 12. So we have here divided by 9, 2. So 1 half. Okay, sorry, this is 1 half. Sorry, 2. This is 2 amps. Okay. So, in another example, if you're given with voltage and set to 12k ohms, what's the current? So, very simple. I is equal to 72. Now, take note of the 12k, so that should be 12,000 or 12 times 10 to the 3. Okay, when you're using a calculator, you should put that way. Well, you can actually write 12k, no, but just make sure that you were able to write it the proper way. So we have here, so this is 5 6, so this is 12 6 over 1,000, so this is 6 times 10 to the uh, 6. Now take note, by the way, so this should be 2.0 amps, no, because we have two significant figures. Now this one we have two significant figures, so we can write 6.0 times 10 to the negative 3. Okay, so it's a good practice, although we can just simply write 6 milliamps. So it's a correct answer, no problem. But later on, you will understand that it's very important, no. So especially in numerical methods, you need to simply um, follow the significant figures. Okay, so for your challenge, so you need to solve this one, no? Very simple, the same process as the so this is your number one challenge for this exercise. Okay, let's proceed to voltage calculation. So the same circuit actually. Okay, now take note, you might wonder, sir, the current flowing here, uh, how come there's no current flowing in this direction? Okay, so it's a very good question. Okay, actually voltmeter has a very high resistance. Okay, you can imagine a very traffic area, so there's no possible car that can passes through, no, because of the very high traffic, no. So but there's still very small but very insignificant amount of current. So whatever the current flowing here will be the same as the current flowing here. Okay, so we just simply ignore the current flowing in this direction. Okay, so that's why I said earlier in the current calculation, you just simply ignore this one as well as this one. For the current, the problem here, sir, there must be a voltage difference or voltage drop in current, in ammeter. So therefore, the voltage here may not be the same as the voltage here. Okay, so if this is 10 volts, so this is might be 9.9 volts. Okay, because the ammeter will consume a bit of voltage, voltage drop. So, but it's very insignificant that you don't include the ammeter. Okay, uh, insignificant means it's not really it cannot affect the 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 circuit. Okay, so you just ignore the voltmeter and then the ammeter when you're looking at the circuit. Okay, suppose that we set the potentiometer to 500 ohms and we measure the current as 20 milliampere. What's the DC voltage? Okay, okay, so we have a new value here. So we have 500 ohms for the resistor. So it's good to write the schematics, no? Although we already have the drawing, but it's good to write the schematics. So we have current instead of voltage given, so we have 20 times 10 to the negative 3, and then we have 500 ohms. Now the problem is looking for voltage. It's very simple. Using Ohm's law, V equals IR, and we have 20 times 10 to the negative 3 times 500. Okay, so then you have 5 times 2, 10,000. So you have 10,000 times, so this is equivalent to 10 volts. Okay, so I think I got it right. So you just cancel the 3 zeros, and yeah, you have 10 volts. Okay, so the answer should be 10. Now, if you look at what is the smallest digit, significant figure, actually, it's only 1. So we have a correct unit. Okay, now this one is capital V and also capital V. Sometimes you might confuse what is V is equals 10V, but this one is the voltage, it's a variable. This one is a unit. So sometimes you write a comma here and then you write the voltage V. Okay, so you don't be confused with that. Then another problem is you set the potentiometer to 2.33k ohms. Okay, that's obvious, and we get 250 milliamps of current. And then what's the voltage? So very simple, V equals IR. So you have 250 times 10 to the negative 3, because it's milli, and then 2.33 times 10 to the 3 because it's kilo. Okay, simply cancel this one, no? The units, and then you multiply the 2. Okay, and then you will get the answer. So it's somehow, if I'm not mistaken, this is around 5, around 600. So I don't have a calculator now, but it's somehow around one third of this, 60, 33, 66, so around 500, 570. Okay, 570. So approximate 570 volts. Okay, so yeah, maybe 580. So okay, so then so this is your challenge exercise number 2. Okay, so that's it. So just remember, in this part we explained voltmeter, high resistance. Okay, actually we have a high resistance voltmeter, so there's no current flowing, equals 0, and then here the voltage drop is equal to 0, approximate or close to 0. It's not, in reality there's always a value on that, no, but it's very small, that very insignificant to affect the circuit. Okay, let's proceed to the resistance calculation. So we have solved voltage and current. Now it's the resistance turn. Okay, so given the same almost the current and voltage, what will be the resistance? What's the value of resistance if the current equals 24 milliamps and the voltage 360 millivolts? So actually from the formula, V equals IR. Okay, so we have here R equals V over I. Now sometimes you get confused with these two, so you might interchange, so I hope you don't. Okay, you just simply memorize the VIR or VIR. Okay, so and then you have 360, and then take note of the unit, times 10 to the negative 3, and then 24 times 10 to the negative 3. So you can cancel this out because these are zeros, okay, 0 0.000 something, so you can think of canceling them. Okay, and then you have 360 divided by 24. So let me see how so 6 4 60. So 60 divided by 4, so this is 12.5. Oh, sorry, this should be 15. Okay, so this is 15 ohms. Okay, so the resistance is 15 ohms. Okay, now another problem. If the voltmeter reads 12 volts, the ammeter shows 2 amps. What's the resistance of? Okay, so very simple. R is equal to 12 divided by 2. So this is very simple, 6 ohms. Okay, so yep. Now take note, there are two significant figures, so it's better to use 6.0 ohms. Okay, so that's it. And then this will be your number 3. So I'd like you to solve it on your own, and almost the same, actually the same process. Okay, so the same formula.